In this video, I'm going to demonstrate the interactive histogram features in Loon. I'm going to do that by looking at two different data sets that are available in R. One is an experimental study on the weights of chicks. The other is an observational study on coronary risk factors. Besides looking at the functionality of the histogram itself, there are a few other takeaways that should be had from this video. First, the familiar histogram is a simple but effective data analysis tool. It shows patterns in the distribution of a bunch of numbers, sometimes expected patterns, sometimes surprising patterns, but in any case, patterns that are going to be of some interest. A static histogram is just one snapshot of that distribution. In contrast, a good direct manipulation interface allows many such snapshots to be seen conveniently and quickly. Second, two or more histograms can be used interactively to explore conditional distributions. And third, an array of interactive histograms is itself a powerful data analysis tool, much greater than the sum of its parts. Many of the features of Loon used to make these points are listed here. You can pause and have a look at these now or come back later. The first demonstration will be an experimental study looking at the weights of chicks given different diets. The idea here is to see which of 4 different diets produce the greatest growth in chicks in a 3-week period. The data is available in R as the chick weight data. This is the analysis I'm going to try to follow in the demonstration. You can pause and have a look at it or come back to it later. So let's start the demonstration in R. So we have data on 50 chicks, these 4 variables, the weight, the day on which the weight was measured, the chick being measured, and the diet number that the chick is being fed. We're going to look at histograms of each of these in turn. Put that away. First things first, we'll need to load Loon. And now I'm going to look at the chick weight itself, draw a histogram of it using the L_hist, the Loon histogram function, and with a bunch of other arguments which don't matter so much. We can change those later. Now, the result I'm going to assign to a variable h so that I can print the histogram out at any time. So executing that, I get a histogram here of the chick weights, and you see that there are a lot of low weights, and then as the weights get heavier and heavier, there are fewer and fewer of them. The frequency decreases. Also, we see that there's an inspector that appeared at the same time as the histogram. This allows us to interact with the histogram in a variety of ways. I could, for example, instead of having the histogram appear on the horizontal axis, I could have it appear on the vertical axis just by swapping them. Move that back. Or I could change any of those argument values that we used when we called the histogram. So I could turn the guides off or on, labels off or on, and so on. One of the first things you might want to do with a histogram is investigate other possible bin widths, because that will give us a little more insight into the distribution itself. So we do that by going to the inspector and checking bin handle. In the histogram now, up pops this little icon at the bottom here. This represents the bin itself. So on the left, I've got a rectangular piece, and on the right, I've got a triangular. The left defines the origin of the bins. So I select that with my left mouse button. I can grab it and move it. As I move it, that changes where the intervals start along the line. And on the right, that's the extent of the bin. So if I do that, I grab that with the left button and stretch it out. The bin widths get larger, and I have greater frequency here. I'm extending beyond the histogram boundaries that we have for our plot. Move it down. And I can investigate that until I get something that I'm kind of comfortable working with, that I want to use to represent the distribution of the weights. So satisfied with that, I'll turn off the bin handle. And one thing you notice that these bars are much lower because we're measuring frequencies here. An alternative is I could put that on a density scale. If I click density, now this area under the dark gray will always be 1. So the histogram itself looks like an estimate of the density of the chick weights. Other things I could change, from the inspector, I could select all of the bars. So if I'm clicking on all, now they're highlighted in a magenta color. That's the highlight color indicating that those are the current bars of current features of interest, which you might want to modify. Modification I can have here, I can change the color. And since we're looking at chicks, I'm just going to give it a nice light yellow color. So I've changed the colors, you can't see them, but I need to turn off the highlighting. I could do that again by selecting none here. We're just clicking on the background of the histogram. So now I've got a nice histogram showing the distribution of the chick weights. So I'm happy with that right now, and I may want to just take a picture of that, just record it as before we start it. And to do that, all I need to do is call the usual plot function, which has been specialized for a Loon histogram. Selecting that and executing it, I'm going to get a nice grid graphics plot here, which I can then zoom in on and export to a PNG or a PDF to use in other documents. So that'll be a static graph just like any other grid graphic. So moving on to the second variable, this is the time at which the measurements were taken. So I'm going to do again an lhist, time, and a number of argument values. But the interesting argument value here is this thing called linking group. This is a string that I'm assigning to this histogram because I know that I want to use this histogram to participate in connected activities with other plots. So executing this, I get the day since hatching, our time variable along the x-axis here, and you can see immediately that, as was observed when we introduced the data, that the measurements are taken every other day, and it's a 3-week study, so this is 0 days, 2 days, 4 days, 6 days, etc. 14 days there. And then at the end, since it's a 3-week study, I've got 20 days and 21 days. That's why we see two right beside each other. The other thing you notice is that the frequency here is declining over time, so it's apparent that some of these chicks are dropping out of the study. We have fewer chicks being measured at the end than we did at the beginning. So if I look over at the inspector, you see that there's the linking group appears here. Chicks, that's the name I gave it. And if I look at the weight of the chicks, its linking group is none. I may want these two to participate in the same group to be linked with one another. So I just select on the linking group, select chicks here. It comes out and says, well, how do you want the display features? Do you want to pull the display features from the other plots in the group, or do you want to push yours out? Since I got these yellow, I'm just going to push these out, clicking that. Now this histogram is taken on all of those display features. So I've got this nice color. So these are linked now, and they're also linked by selection. So if I can select any one of these bars just by left clicking on it, and when I do that, you'll see over in the histogram at the left, what I've done is I've conditioned on this particular day. So this is day 6, day 8. And now in the magenta over here, what I see is the conditional distribution of the chick weights on the 8th day of measurement. Whereas the yellow is looking at all of them, I'm only looking at the conditional distribution now. And I can do that for any day. If I want to look at multiple days, I can do that in a variety of ways. By just holding the shift key, I can pick off more days and see the conditional distribution. And finally, I could just sweep out like this, a rectangle, and select a bunch of them. So what I'm doing is I'm doing a query, making sure I'm looking at the data from 8 days and before. Get some sense of how the distribution here, the conditional distribution changes over time with the weights. In this histogram, I'm going to turn on brushing. And that happens by going over to the inspector, and where it says selecting by, the dynamic selection, instead of sweeping, which was sweeping at that rectangle, I'm going to check brushing. Now I've got a little rectangle up here which I can shape by grabbing this corner, and now that becomes something that will follow the mouse around. And that lets me go change things in time. So as I brush early in the study, I can see the conditional distribution of the weights piled up on the left, as you'd expect since they were just hatched. And moving that along, watch how that conditional distribution changes over time. And you see the average gets larger and larger as the chicks are growing. But the also thing you notice is that the variation gets larger. So even though we're near the end of the study, we've got still some very small chicks in addition to the very large chicks that we have at the end of the study. Okay, so that's brushing. You can do that with any of the histograms. I'm just going to turn that off. So we're back, and we'll look at the next variable. So the next variable, well, is the chick identification itself. So Here we're taking the Loon histogram of a chick and having it participate in the linking group. So as soon as it's created, it's going to pick up the feature that we've already identified, that yellow color. So looking at this histogram, I'll move this over here actually. Looking at this histogram, we can see the IDs of the chicks. These two histograms together kind of tell us a lot about the design of the study, measuring sort of over these days, and then looking at the chicks here, the chick ID. You can see that this first chick, there are only a couple measurements on them. The other one, there are only a couple, etc. And if I look at the last bar over here in the hatching, you can see that at the last day, these chicks had dropped out of the study. In fact, all of these chicks had dropped out over time, these ones where they're not up to the full 12 measurements taken. So turn that off. I think I'll just go on to the next. A most important variable, and that is the diet. So this is the experimental variable that we're trying to see what the effect is of each diet on the weight. Participate in the same linking group. And I'll move that down here underneath the weight of the chicks. And I can begin to ask questions about these different diets. I see, for example, the normal diet has nearly twice as many observations as the three experimental diets. If I select any one of these, there's the normal diet. I can see the distribution of the chick weight appearing here. For the 10%, I think, protein diet, we can see the distribution. It's at 20% and 40%. And you can also see when we look at the study that for any one of these diets, for example, this last one is going to be the chicks who have the highest ID numbers on the right, in that they are measured, except for the ones that have dropped out of the study here, measured equally over all of the days. So just to get to the which of these guys are best, I want to look at what's going on in the last week of the study. That is over here, these last bit. And what I'm going to do is I'm going to take this sweeping here, select all of these bars that go up to cover the first 2 weeks of the study. Now that I've highlighted those, you can see where they appear in our experimental diets and the chick IDs, and we've got across all IDs. So I go to the inspector and I choose to deactivate these. That's going to just take these out of the study itself. So now the plots adapt. These two plots haven't changed much. They're under frequency vertical axis, but these two have changed to adapt because they want to preserve the density. Both of these are density plots. So now this is just the weights of the distribution of the chick weights in the last week of the study. And that's kind of where we're interested in knowing how well these various diets are doing. So one way of doing it is let's just look at, just to keep this analysis short, just look at all the large chick weights. And you see certainly that that's happened towards the end, but it's pretty clear that this is diet 3 that's winning. Okay, so that's just a very quick run over of how you could use histograms to analyze the data in this experiment. There's lots more you can do, but I think I'll leave it at that you quickly get a sense of what's the winning diet and what are the characteristics of the data set itself. The second demonstration and some concluding remarks, including references, appear in part 2.